The final sequential data type in Python that we're going to cover is the dictionary. So this is a compound data type somewhat similar to strings, lists, and tuple in that they're sequences of items, but just like we saw with strings, lists, and tuples, there are particular differences among the data types, and maybe a few more differences with dictionaries. So dictionaries are a sequence of key and value pairs. They're marked on at the beginning and at the end with those curly brackets or braces, you might hear them called. Um, each item is a pair of a key and a value, the key being to the left of a colon, the value being to the right. And these key value pairs are separated in the sequence with commas. Now, kind of particularly, like I said, a little bit strange here, the order of the key value pairs in a dictionary doesn't stay the same as when you enter it or when you reference it, and it doesn't really matter. That, in turn, affects the way that we can refer to specific items in the dictionary. They don't have an index position like with the strings, lists, and tuple items would. There are two ways to create a dictionary. One is to simply assign it values. So you would type it in here. Here a variable called eng to sp, English to Spanish, signified there, being assigned a value of a dictionary with 3 items, so 3 pairs here. The 3 keys are the English words 1, 2, 3 strings, and the 3 values are uno, dos, and tres. All the objects in those key value pairs are strings. So the colons separate the key and the value in a single item, and commas separate those items in the dictionary. So you can reference a specific value, here, Spanish word dos, by using square brackets after the name of the variable and entering the value of the key that's paired to that value. So if you print into Spanish bracket 2, and that kind of looks up the key there, what will get printed out is the value dos, the value associated with that key. So here, if you tried to enter a dictionary where 2 of the same keys are used, the integer 1 and the integer 1, you get an error. Values can be repeated in a dictionary, but the keys must be unique. So the other way that you can kind of fill in a dictionary is to initially assign a variable an empty dictionary. Just open curly bracket, close curly bracket. And then assigning values to a key. The key doesn't have to exist. If it does, the value associated with it will be replaced. But if it doesn't exist, then it is created. So this is an assignment statement where this variable already exists in the code, but it's an empty dictionary. The value is being assigned to a key location. And even though that key didn't exist before, it does after the execution of that statement. And you can keep repeating that. So just some quick facts about dictionaries. Keys do not have to be the same type. Some could be integers, others could be strings. Similarly for values, they don't need to be the same type. A key and its associated value can be of different types. You could have string keys and numbers for values, is quite common. And the order of the items, an item being a key value pair, it doesn't matter, and it's not remembered by the interpreter. We'll take a look at some of the operations that can be performed on dictionaries using tokens, um, functions, and the methods or built-in functions that are designed to act on inventory or on dictionary objects only. So here, a 4-item dictionary is created. So the variable is called inventory, and what's being assigned? 4 key value pairs where the keys are strings, names of fruit, and the values are these integer numbers, kind of the number of fruit that maybe a store has in stock. So we can print out the entire inventory. You can delete an element by referencing its key. So if you write del inventory followed by square brackets and then the name of the key pairs, then that item is going to be deleted. So the pairs goes away, but also the associated value of 217. And you can call the length function. After you've deleted the pairs item, there are only 3 items left. So even though you see maybe 6 different data objects within that dictionary, 3 of them are keys, 3 of them are values, and so you have 3 pairs of those. As for methods or functions that are written and built in to act on dictionary objects, you can call the keys method, which will print out a list or return a list, I should say. It doesn't necessarily print it out. It will return a list of all the keys present in a dictionary. Dot values, so you would write that the name of the dictionary variable, dot values, will return a list of all the values. And if you call dot items, it will return a list, and the elements of that list will be tuples. So this is kind of, as you see, it's all enclosed in square brackets, so it's a list with 3 items. Each item is a tuple with 2 items, the key and the value. In Python 2, you can call the has underscore key method on your dictionary to ask whether or not to return a Boolean value indicative of whether or not that key is a key in the dictionary. In Python 3, you simply reference the name of the key value in the name of the dictionary, and that will return a Boolean, true or false. And here's a slide that just covers the difference between the functions that we've defined and some of the functions that might be built in, like the print function, which is simply called using the name of the function followed by parentheses with any parameters in the middle. A method is a built-in function that's designed to only work on certain objects. And so what you would do to call these methods, which are functions, is to write the name of the variable that the function will act on. Follow that by a period, the name of the method, and then parentheses. And you can enter arguments here if the method is designed to use those. So one of these might be list.sort, spring.split, as we see in the lab. As we saw with lists, if you're going to try to copy dictionaries, be aware of the difference between shallow and deep copying. So here we might have a dictionary sizes. S for small is 28, maybe like a chest size or a pant waist size. M would be 32, L 36, XL 40. So if you tried to create sizes new by assigning it all the values that are currently assigned to the variable sizes, and then delete one of the items, it would affect the original dictionary. So this sizes new equals sizes is not creating a new object in memory. It's simply It's simply creating a new variable name to reference the same object. Now, if you want to create a deep copy, a brand new object that still has the same values, key item pairs, you can't do it in the same way as a list because where you might follow the name of sizes with a bracket, colon, close bracket, because the same kind of indexing and slicing is not on offer for dictionaries. It doesn't make sense when the order can change. So there's a built-in function, a method called .copy. So you could write sizes equals that, sizes new. If you wanted to create a deep copy, equals sizes.copy. So now if you delete one of the items in size new, it only affects size new, and the original is not affected. Saw how lists, really how nested lists like this, can be used to represent matrices, two-dimensional uh, arrangements of numbers, such as a raster image, kind of a image maybe from a satellite sensor used in GIS. So nested lists are a common, a useful way to represent those data. Sometimes spatial data, where could be represented by a sparse matrix or a gridded image where most of the values are zero or are the same anyway, but a few grid cells would have a different value. You might represent that image or that data using a dictionary. So in here, matrix is a dictionary where the keys are two item tuples, kind of a row and a column location. And then the value is what we see in the image, the numerical value. So this might be useful for these sparse matrices where nearly all of the values are zero. But if you need to kind of have a key value pair for every pixel, then you're not going to be really saving any space in memory. Here's the .get method to reference matrix elements. So you provide a key, default value. It's kind of a reading a matrix here. So dictionaries are not, the items in dictionaries are not arranged in any kind of sensical order. They get printed out left to right in a certain order, but it's not one that you can necessarily anticipate based on, say, alphabetical order or someone. So it might be desirable to sort the dictionary on that basis, just for a given application. You can extract the information from a dictionary using the .items method, which yields, again, a list of all of the key value pairs as two item tuples. You could then loop through keys. For key in, the name of the dictionary .keys, print the key. So here, if you had a legend information for kind of land use, land cover types, with numerical values that could be represented in a matrix, what's the word that goes with it? So here the keys are numbers, values are strings. Since the .keys method outputs a list, that's a sequential form that can be looped through. For key in dict input.keys, print the key. Similarly for values, if you call the .values method on a dictionary object, and loop through all the values, print those out. And if you call the .items method, remember that's a list of tuples, you can loop through those using a tuple as the looping variable. So for parenthesis, key, comma, value, close parenthesis, in the dictionary.items. So this whole thing is a list. So it can be looped through using a for loop. But it's a list of 2-item tuples. So that's the structure of the looping variable. Print then the key and then the value. So you can get the entire legend information printed out. Something else to mention, just global variables, things you might have trouble with in a code. If you have a variable that you want to reference multiple times in a script, maybe different functions, with the same value, you can do so by assigning it a value, initializing that outside of a function, and then referencing it within. Now, one thing that you need to do, though, if you want to reference variables in this way without error, is to initialize it within the function as a global variable. So whereas this script, count equals 0, +1 to increment count, would throw an error because count was never initialized within the function. If you simply reference it here, global count, the function would work. So some of these methods, .sort, .split, .append, extend, remove, or the del operator, del token, things that could be useful in the lab exercise.